Okay, to continue this exercise, what we're going to do is we're going to now add a component. And by component, if I look at the test actor as an example, by components I mean the things that you can composite the actor based on. So in this case, it's got a default scene root and a mesh component that shows the model. The actor blueprint is the sort of container for all of these components. So what we're going to do is we're going to create a new component type. So if we go to our C++, new C++ class, and what we want is actor component as our base class. So if we select next, let's call it Rotator component, if we can spell it properly. Let's call it TestRotator. Yeah, call it TestRotator component because, well, just because. So we'll create that class. That'll add it to the new project. It'll create the Visual Studio solution again. It'll do a hot reload. So all of the stuff it's been doing normally. So what we've got now, if we go to Visual Studio, is this TestRotator. If we can find it there. And it's got the usual begin play, but what it's got also, if you look at it, it's just slightly different. It's not doing tick, it's doing tick component. Now it seems a bit weird that it's doing that. And it's also got tick type and the tick function that's being called. Let's not worry about that for now, though. So what properties do we want for this thing? Well, we probably want a... It's just... I shall just make that bigger again. We probably want a float for a rotation speed. And remember to initialize it. And then we'll declare this as a property. Edit anywhere again because we do want to edit it. So this edit anywhere thing, by the way, it just changes how it's visible in the editor. You can right click on edit anywhere and go to its definition. You'll find a few different values in there. There are some documentation items on it, but it's not really that obvious. But for now, just have edit anywhere for things that you want to be editable in the edit interface. And the category we'll call movement again. So we've declared that property and we can now use it. So we just go to our TestRotator. And this time we're going to fill in the tick component because that's the thing that's going to get called every frame, every sort of update. And all we're going to do is we're going to get owner. Now, get owner is, because this is a component that's added to an actor, the owner is the actual sort of actor, the sort of collection component thing that's holding all of these subcomponents. So get owner will give us that, and then we can do get actor rotation. Now that returns a new type called an f-rotator. Current rot equals get actor rotation. So now that we've got current rot, we can call a function, and in this case we're just going to use the add, and we want to add, and it says here add is pitch, yaw and roll, and we want to obviously change the yaw, well maybe not obviously, but for this exercise let's just change the yaw, so we'll leave the pitch as it is. We'll delta time times a rotation speed for the yaw, and we'll roll by 0.0f. So basically just add some rotation in the yaw direction. We could do a negative there if we wanted to change the opposite direction, but anyway. And then we just do get owner set actor rotation. and pass the current rot into it. So all we're really doing here is adding a bit of delta to the yaw axis of this actor, or the actor that's owned by this component. So it's a really simple bit of code, 3 lines, and we've got this changed. Now what we need to do then is we go to the object type that we want to be able to rotate, and in this case we're going to our test actor, and all we need to do is go for our component, which I can't remember, we call it TestRotator, right? And we add a TestRotator component. So you can add and remove components as you need. So if you look at it, we've got in our let's just compile that so we've got the right thing. If we then click on our current rotator, it should be somewhere in here. Because these actors, the ones in the world, are based off that blueprint, they get the value for this component. Oh, did we? Let's go to TestRotator component. Edit anywhere. Category equals movement. Yeah. Rotation speed. Oh, it didn't. That's why. We've got to remember to compile the code. So because we've changed it. So this is the original version, didn't have the rotation in. Now we've got to compile and hot reload again because we've added that variable. So now that we've compiled it, you can see that it's loaded up that new rotation speed value. What that means is that we can edit this, let's say, I don't know, 90 degrees, something like that. And if we simulate that now, we get a rotating platform. So as you can see, there's some quite powerful ideas coming here. Actually, I'm just interested to see what will happen if I jump onto that thing. Did I rotate with it? Yes, I do. Oh, that's bad. Yeah, don't do that. Bad for your eyes. Yeah, so the interesting thing here is that we can then composite a lot of our behavior by adding components. And there are a bunch of already existing components here, some of them which work better than others. And the interesting thing is that you can plug in events into the event graph of your actor blueprint and handle them from your components. So you can get the value of this guy and set rotation. Sorry, rotation. Oh, of course. So one thing you should be aware of, let's just check this out, is that, okay, we can edit it anywhere, but we need to say blueprint read write. And what the blueprint read write does is it allows us to edit the thing in the actor's blueprint. So let's just compile that. So if we go to the component now, we should have if you see set rotation. Okay. So what you can do and what that means is that once it's blueprint read write, you can actually get the component and you can change a property on it. So from the blueprint, so we can do set rotation speed on the actual component, and we could change the default value, say on begin play. So you know, we could say, okay, now the value goes up to 180 when we start. So that's how you would give designers access to the variables that you create in C++. So by default now, when it begins play, it'll actually set the rotation speed for all the objects. And generally that's what you want to do, is you want to work on code in C++ and make sure its properties and functions are available to your designers. So look at this blueprint read write, edit anywhere, visible anywhere, those kind of things, and just see what they actually mean. But what that means is that you can then allow the interface to be changed in the blueprint, which is what the designer guys will be doing a lot. So people you work with would generally work with your interface, and you'd be the guy doing the underlying code for it all. And there's a whole bunch of stuff. There's a huge amount of stuff this does. It's all run through the Unreal header tool and the Unreal build tool. So none of this is standard Visual Studio or standard C++ stuff. So just be aware of that. If there are errors, it's going to come through the Unreal build process. So let's just try that. So that's what we get. We get a rotation rate because it's overridden in the blueprint for this particular thing. If we create another one, and let's just make this guy a bit bigger so we can see him, 10 by 10, and we play that, you can see that this guy's should have 180 degrees, I think it is, as a rotation rate. Yeah, so the blueprint's kind of given a default value to that thing, and because it isn't derived, actually is derived from that, but it hasn't got any variables, so it won't bob up and down. So there you go. Actors and actor components are kind of the meat and potatoes of coding gameplay objects in Unreal Engine. There are a lot of other classes that we'll come to fairly soon, but that's the basics of creating gameplay behavior in Unreal. So yeah, okay, thanks for watching, and we'll get on to the next bit.